Now that you understand that an exponential and a log are intrinsically related, I want to make sure that that link becomes even more clear in question number 4, because the basic principle that you need to understand about logs, if there's one thing that you understand this year about logs, no matter what, before going into math analysis, it's the fact that logs are essentially the opposites of exponentials, and that every exponential expression can be written with a log, just as every log expression can be written as an exponential. You kind of saw that in question number 2, that every log expression can be rewritten in exponential form. So you may want to think of question number 4 as the reverse of question number 2. Namely, that we're going to piece together a log expression that rewrites the exact same numbers in this exponential here. So in letter A, 2 to the power of x equals 16, with that log structure. The thing to recognize about a log structure is that it generally has 4 components. The first of which is the word log. The word log is actually important. So as strange as it is, you'll need to get used to writing that word log. And I know it's a little odd because usually when we write exponentials and all the other expressions in algebra, we're using numbers and maybe occasionally like an x. Log is the first operation we've seen since maybe geometry where we actually write letters. I'll remind you, sine, cos, tan, those are operations, those are functions, and they involve letters. So log is much like sine, cos, and tan in that way. It's just a function that we call by its name, and we write its name instead of a little symbol or something like that. So once you write log, the next key thing that we have to know how to place is the subscript. So I'm making a little yellow dot there to indicate we need to understand what the subscript is going to be. Following the subscript, we then need to know what number goes after the log and the subscript. We call the subscript the base, by the way. So the number that is attached to the log and its base is this one that I'm going to put in the pink spot there. And then equals something on the other side. So I'll just give it a blue placeholder there. Our goal is to rewrite the original problem, 2 to the power of x equals 16, so that each of those pieces, the 2, the x, and the 16, fit within these pink, yellow, and blue boxes. Now, if it helps, you can always recreate the pattern that we saw in question number 2. That little arrow may come in handy here. So if I redraw the arrow just to remind myself the order in which we saw the log pattern emerge, maybe now we can look at it through a clearer lens. We know that the base of the exponential expression is the subscript of the log. We actually call it the base of the log for that reason. Base of the exponential, base of the log. So we can predict that that base is going to be a 2, because the base of the exponential expression was always the same as the subscript in the log. Now, in terms of the order of things, we always started with that base and raised it to the power of whatever was over here on the right-hand side after the equal sign. So if I look at this exponential expression, that's giving me a huge hint that the thing in that box must have been the x, because the exponential expression clearly said 2 to the power of x. So I know that the x must be the blue part, and then equals, as we loop back around, the 16 must be the pink part here, because we know that the answer to that exponential expression always belonged in that sort of center of the problem, the number attached to the log and its subscript. We pronounce this log base 2 of 16 equals x. So just in case you need to start kind of saying this to yourself, that's how we say it as mathematicians. Log base 2 of 16 equals x. Practice saying a few of the problems as you finish them so that you can start to build that lingo, since it is a little different than some of the things that we normally say in a math class. Now, we're not going to necessarily worry too much about solving for x in this log expression, because I don't think the log expression makes it very clear. I would just look at the exponential and ask yourself, well, what would x have to be in order to make that exponential expression work? 2 to the power of something is 16. Oh, well, we know 2 to the power of 4 is 16, so x must be 4. The log doesn't really help us with that. It's more just something that you can think of as the original expressions guide. And if you want to, you can always start by doing the exponential part first, solving for x, and then worrying about the log afterwards, especially if that helps you feel more comfortable with what you're doing. For instance, in letter B, we can already predict what x is going to be. Something cubed is 27. We know that 3 cubed is 27. X is automatically going to be 3. So again, you don't have to conflate the two ideas. If you can figure out what x is on your own, then you can go ahead and just do all the x's first, then go back and do all the logs. As you're practicing logs, you can definitely practice writing it with that color coding in mind if it helps. And sometimes I like to take my color coding parts to the next level and really try to correlate them with the original problem. So log base something of something equals, and then whatever number was here. Okay, so let's see if we can match things up. We know that generally speaking, the base of the exponential was the subscript of the log, so this must be our x. And if you want to, again, take your color coding to the next level, you can even highlight there. The x is yellow, so you can match it up. We know that when we draw the little arrow in a log expression, x to the power of the blue equals the pink. So if you want to use the color lingo there, yellow to the power of blue equals pink. And we can definitely see that correlation really clearly in this exponential expression. Yellow to the power of blue equals pink. And if I highlight it, it becomes really obvious what goes where. The blue number must be the 3, and the pink number must be the 27. When you're writing your log expression, do try to practice making things the correct size. Namely, the 27 and the 3 should roughly be the same height as the letter L in the word log. They should all kind of be lined up and look like you're normally writing in a sentence. But the X should be the odd one out. The X should be the subscript that's teenier and lower than all of the other parts that you're writing. In any case, make sure that that makes sense, because if it does, you might be able to quickly correlate all the other problems to this pattern and have a faster way of making sense of it. Again, you can start with just the solving for x part. 3 to the power of something, or sorry, 3 to the power of 4 is going to be something. 3 to the power of 4 is 3 times 3 times 3 times 3 to 4 times. We know that's 81, so we can get x out of the way right off the bat. And then we can remember our log expression. If at this point you still want to use the color coding, that's great. If you feel as though you don't need it anymore, that's fine too. You can decide for yourself, because you know your brain best. You know if your brain responds to color, responds to other sorts of patterns, responds to audible clues, or something else entirely. So I'll just one more time do that quick little visual. I'll also include that little arrow just to remind myself of the order. I personally like that little arrow because it always sticks with me. And I can remind myself that the base to the power of the blue is always going to equal the pink. So I can translate this. The base or subscript must be 3. To the power of this blue piece must be 4. And, sorry, darken that there so you can see it. And the answer, the result, must be the x. And again, if you want to color code it just so you can see it clearly, you'll see that your colors are definitely going to match the exact same colors in the exact same positions that you had in letter B. Some people appreciate that consistency, especially when we're learning something new that might not make sense, so that would be a good thing to pursue if you can. Now that you've seen a few examples, seen that it gets really repetitive, try to finish question number 4 and get comfortable with the rewriting process so that you can start to build that connection between an exponential and its log structure. In the next question, we're going to go backwards. We're going to start with a log and write it as an exponential. So understanding this dynamic both forwards and backwards is so crucial.